Hello, good morning everyone. Good afternoon everyone. I am Sruthy M L. So if you're wondering, ML does not stand for machine learning. I am a software engineer in key value software systems. And I just enjoy making things. Yeah. So here I'm here to talk about the AI-powered device that I made back in college. So it's a bit scrappy, if I may. So the idea was to essentially build a portable computer vision system that combines embedded ML principles, but I had to go for the cloud-based AI inference because I could not just get the hands on the right hardware for it. Yeah, so the core idea was to create something that could capture images, process them, and identify objects and display information all in one compact, portable form. So, yeah. So the system architecture I went for centers around two microcontrollers working in tandem, the ESP32 and the Teensy microcontroller. So we used an ESP32 for wireless connectivity and a Teensy for handling the camera interface and the display. So an obvious choice would be to go for a Raspberry Pi because it has all of this included, integrated in Raspberry Pi itself. But I went for Teensy and ESP32 because it was just what I could get my hands around at the time. So the hardware pipeline begins with the image capture through the overcame module connected via I2C. The images are then processed by the TensorFlow Lite model, specifically the MobileNet V2, which is the best for mobile devices. So this model identifies objects in the images, and a Flask-based API retrieves relevant information about the object and returns the information. Thank you. So the hardware implementation. So for the hardware implementation, we designed a custom PCB that integrates all the components. The AutoCAM module communicates via I2C with the microcontroller, allowing us to trigger image capture with a physical button. We implemented thorough testing of the camera interface through the pixel clock transmission. One of the technical challenges was converting the image and transmitting image data, which we solved by encoding the image in a base64 format before sending them to our processing endpoint. So the software stack, we deployed a TensorFlow model using Keras, specifically optimizing the MobileNet V2 for our use case. This runs on a Flask server that exposes a REST API endpoint. When the device captures an image, it sends it to the endpoint where the model performs the inference to identify the object. Yeah, so the entire pipeline from the image capture to the information display takes around like 2 seconds.
You're almost at time.
Yeah, so this is the result. The object detection accuracy was around 90%, and the response time was around 2 seconds. And I could get everything displayed on the hardware in just 2 seconds. Yeah, thank you.
Thank you so much. Ken Chan, are you in the room? No, Ken Chan? Okay.